and achievements. Chandrayaan's legacy began with Chandrayaan-1 in 2008, leading to groundbreaking revelations like the discovery of water molecules and comprehensive lunar mapping. Chandrayaan-2 took us even closer to the lunar surface. Though the soft landing was unsuccessful, the orbiter's ongoing study exemplifies the lasting legacy. Chandrayaan-3 is the proud successor of Chandrayaan-2, with advancements in technology and meticulously designed payloads. This mission seeks to explore and understand the moon's mysteries like never before. Chandrayaan-3 objectives are three: a soft landing, rover roving, and in situ scientific experiments. So let's talk a bit about the scientific experiments and the payloads. Let's start with the lander. It has got CHASTE, C-H-A-S-T-E, Chandrayaan Surface Thermophysical Experiment. This experiment will measure the thermal properties of the lunar surface to understand its thermal behavior. ILSA or ILSA instrument or lunar seismic activity is designed to detect seismic activities on the moon. ILSA will help understand the lunar interior and tectonic activities. The third is LRA, Laser Retro Reflector Array. In collaboration with NASA, this passive experiment will allow precise measurement of the distance between Earth and the lander. The second part is the rover Pragyan. Our rover is not just a vehicle, it's a state-of-the-art laboratory. It will uncover the lunar soil's elements composition and geochemical properties. LIBS, or the laser-induced breakdown spectrometer, will be used to analyze the elemental composition of the lunar soil. It works by focusing a laser on the soil, creating a plasma, and analyzing the emitted light to determine the element's presence. The APXS, or alpha particle X-ray spectrometer, will measure the abundance of elements in lunar rock and soil by bombarding them with alpha particles and X-ray. It is valuable in studying the moon's geochemical properties. The rover features 6 wheels and a suspension system to traverse the lunar terrain. Solar panels provide the power to the rover, and rechargeable batteries store energy during the lunar night. Navigation cameras and onboard intelligence enable the rover to navigate autonomously. The rover communicates with the lander via a dedicated communication system. It ensures seamless data transmission, including images, analysis results, and telemetry. Soft landing on bodies in space are tough. As Amitabh Ghosh, a scientist for NASA's rover mission to Mars, explained to a newspaper, imagine a spacecraft hurtling through the space at 10 times the speed of an airplane, having to come to a standstill to land gently, all in a matter of few minutes, and more importantly, without any human intervention. However, Chandrayaan-3's lander module has notable updates, including reinforced legs, more instruments, updated software with multiple redundancies, and a bigger fuel tank, crucial for any last-minute changes. Communication is also vital here. It is very important for a successful mission. Chandrayaan-3 uses the IDSN, or Indian Deep Space Network, for communication between propulsion module and lander module. Once the lander module has successfully touched the surface of the moon, the rover will be deployed. The rover will conduct experiments on the moon's surface, operating for 1 lunar day or 14 Earth days. Unfortunately, the rover lacks the thermal insulation required to survive the frigid temperatures of the lunar night. The rover will communicate only with the lander, while the Chandrayaan-2 orbiter acts as a contingency link, ensuring uninterrupted data flow. Now let's talk about the landing site. The landing site at the lunar South Pole is not just a destination, but a gateway to uncharted territories. With 1 lunar day mission life, the clock is ticking for our lander and rover to conduct vital experiments. But why the lunar South Pole? This unexplored region holds vast scientific and economic potential. Rich in water ice and other valuable resources, it presents opportunities for sustainable exploration. Understanding the South Pole can reveal clues about Moon's history, evolution, and even the origins of life in our solar system. So please mark your calendar for August 23, when Chandrayaan-3